Kind of remember slope? How do you describe slope? Rise over run. It's the steepness of the line. The higher the slope, the steeper the line is. Okay? Rise over run. Rise is my change in my vertical height, which is my y coordinates, my change in my y coordinates. The run is my horizontal length, which is the change in my x coordinates. So if we look at line segments AB and CD. If I go from A to B, what's my rise? Oh, that's okay. Apparently Siri likes my voice right now. How do I go from A to B? What's my rise? 3. I go up 3. What's my run? So I go up 3 and then I go over 6. Would I leave this as 3 over 6?
Can you make it 1 over 3?
Not 1 over 3. 1 over
2.
2. And yes, I would make it 1 over 2. I would simplify my fraction. Okay, let's go from C to D. What did I do there? How do I show down? Negative 3. And then what was my run?
4.
4. And question C says, does it matter if the slope in part B is calculated using the 2 endpoints of the line or any 2 points found on the line? So could I use any 2 points found on the line? Could I go from here to here? Or actually, I think it should be more so with A. Oh, I see. I did that part wrong. There we go. This goes up here. So this was the slope CD. And the blue one was the slope AB. I was reading that wrong. Because in part B, you're asked to calculate the slope using the formula. So if I did the slope of AB, I need y coordinates. So I need to figure out what are my coordinates for point A.
One and 8.
1 and 8. And what are the coordinates for B?
7 and 11.
Okay. So it's the difference in my y coordinates, 11 minus 8, over the difference in my x coordinates, 7 minus 1. I still get 3 over 6, which still reduces down to 1/2. What are the coordinates for point C?
6 and 5.
And for D?
10 and 2.
So the slope for line segment CD, the difference in the y coordinates, 5 minus 2, divided by the difference in the x coordinates, 6 minus 10. I get 3 over negative 4, which is the same as negative 3 over 4.
So we could just do that coordinate one instead of making that extra line.
Yep. Instead of counting, yes, we could. Okay? But in part C, it says, did I have to use the endpoints? So could I have found another point on the line? For example, this is a coordinate right here. What is the coordinate of that point?
3 and 9.
If I had used my formula, 11 minus 9 over 7 minus 3. What's 11 minus 9? 7 minus 3.
4.
Which still reduces down to 1/2. So does it matter which 2 points I pick on the graph?
No.
No. In this one right here, would it have been reasonable to pick any other point other than the C and the D? Why not?
Because they don't match up.
Because there's no other point that's matching up. This right here is not a nice point, or even this one, which is 8 over, going up. It might be 3.5, it might not be. So I want to make sure that the coordinate I pick, I recognize and I know that that's an actual coordinate. So does it matter? No. Slope is constant on a straight line. Okay, let's see how much of this you remember from last year. So how do I describe slope again? It's the steepness of a line. So slope is the ratio of the vertical change, which we call the R word, rise, over the horizontal change, which we call the run. If I have a line segment that rises from left to right, so that was line segment AB. What can you tell me about the difference between line segment AB, which went up, and line segment CD, which went down? Other than the numbers were different, what else was different about the two numbers?
One was negative, one was positive.
Which one was positive?
The one going up.
The one going up. So if it goes up from left to right, it has a positive slope. If it goes down from left to right, it will have a negative slope. Okay. So let's think of a horizontal line segment. What can you tell me about the rise of a horizontal line? There is no rise. So the rise over run is going to be 0 over something. Let's call it some value of x. Well, what's 0 divided by x? 0. So a horizontal line segment would have a slope of 0. A vertical line. Vertical line has a rise, but what can you tell me about its run?
None.
It doesn't, it's 0. It doesn't have a run. So if I do that rise over run again, my rise is a y value over 0. Can you divide by 0? So we say that it is an undefined slope. And finally, the slopes of all line segments on a line are, so if this is my line, and I calculate the slope from point A to point B, and from point B to point C, and point C to point D, what can you tell me about the slopes of each of those segments? They're the same. Seven, 8, and 14. Accuracy and precision, I'm not going to do questions on it, but really what it comes down to is accuracy refers to how close a measurement is to its real value. Precision determines how consistent it is to that value. So the one example, and I'm not going to go through it, but if I was to throw darts at a board where the goal is to throw as many darts as possible in the center of a board, well, I've got a cluster here, and then I've got this all over the place. This is an example of precision. I hit the same spot every time. I'm consistently in the same spot. This is accuracy with precision. Not only am I in the same spot, I'm in the spot that I'm supposed to be in. This one, neither one. Okay? Another example of accuracy and precision in track and field. When you're using the tape measure, sometimes different tape measures are a little bit different because the nylon thread has stretched or it's relaxed or it's tightened up. But as long as if I was measuring in a single event using this same tape measure, I'm still precise because I'm using the same measuring tool. Okay, that's it.